Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over an exercise where we're going to find the center of mass of a two-dimensional system. We have two exercises to go over. In the first one, we have three different masses located at three different locations, and we're going to find the center of mass with three of those masses. And in the second part of the question, we have in fact five different masses located on the XY plane at different locations, and we want to find out where the center of mass of this two-dimensional system is. Okay, so to achieve, get started, we need a set of formulas to be able to come up with the center of mass. Let me just quickly go over that, and then you're going to see the same table within the rest of the video. So let's say we have n masses located at n different locations, which are provided as x1, y1, x2, y2 through xn, yn. We have m1 through mn. These are the masses. Okay, so first we're going to find a moment about y-axis, and we're going to call that to be m sub y. It's m1 x1 through mn xn. And we're going to find a moment about x-axis, that's m sub x. And by using moments about x and y axes, we're going to find the center of mass, which comes with the coordinate x bar and y bar, as the ratio of my divided by little m and m sub x divided by little m, respectively. And here m is the total mass. You have n of them, you're going to take the sum of those. So we're going to use this set of formula for the rest of the video. Let's get started. All right, let's take care of part A. So we're going to find the center of mass of the given system of point masses. We are given the masses 5, 1, 3 located at the points 2, 2, negative 3, 1, and 1, and negative 4. So what we're going to do here is just, I want to remind you this formula here. If you have like n masses like m1 through mn, located at x1, y1, x2, y2, all the way to xn, yn. So you can actually find a moment about y-axis represented by m sub y as the summation of m1, x1 all the way to mn, xn. And the moment about x-axis is the summation of m1, y1 all the way to mn, yn. Okay, so we're using the y-coordinates to be able to find the moment about x-axis, m sub x. And eventually, the center of mass, x bar and y bar, is found by two ratios, m sub y divided by little m, and m sub x divided by little m. And m, little m, is the sum of the masses. All right. So why don't we go ahead and then use the formula here. And here we go. So I just copied those formulas down. And since we're asked to find the center of mass, so this is exactly what we need. Okay, so we have m1 to be 5, m2 to be 1, and m3 to be 3. And these guys are all x1, y1, x2, y2, and x3, y3. So these are all provided to us. So all we're going to do is just to plug in those numbers and see what the coordinates of the center of mass are. Okay, so m1 is 5, so 5 times x1, that's 2, plus m2 is 1 times x2, that is negative 3. Okay, plus m3 equals 3, so 3 times x3, that's equal to 1, and divided by the sum of the masses. Okay. So what is the sum of the masses? 5 plus 1 plus 3. And also let's look at m1, y1. So 5 times 2 plus m2, y2. Right, m2 is 1. y2 is 1. And m3 times y3, that's negative 4. 3 times negative 4 divided by 5 plus 1 plus 3. Okay? All right, so let me just write down x bar here. X bar is going to be 10 minus 3 plus 3, so 10 divided by 9. and y bar is going to be 10, 11, negative 12, so negative 1 over 9. All right, so center of mass is going to come with the coordinates 10 over 9 and minus 1 over 9. Okay. All right. So I think that takes care of part A. Let's finish part B as well in the same video. Let me just copy those formulas down there, and I'll see you at the next slide. All right, so I just copied the formulas down. This time we have 5 masses, and for that reason we have 5 different locations here. And we have M1, X1, Y1 here. Okay, M2, X2, Y2, M3, X3, Y3, M4, X3, Y4, and M5, X5, and Y5. So all I'm going to do now is to plug in M1, MI, XI, and YI all the way back into the formulas here. Okay. So let's see what x bar looks like. X bar is going to be 3 times 2 plus 4 times negative 3 plus 2 times 1 plus 1 times 0 plus 6 times negative 3, and all divided by 3 plus 4 plus 2 plus 1 plus 6. Right? Please go ahead and get this calculated. And this is what I got here. So negative 22 divided by 16. I'm going to go ahead and write this down here. Okay. And I'm going to erase this portion, and then the bottoms are the same. So I'm going to write y bar here. Okay. So let's write y bar. Okay. So you're going to have the mass times M1 times Y1, so 3 times 2 plus 4 times 1 plus 2 times negative 4 plus 1 times 0, right? 1 times 0. And then 6 times 0. Okay. Well, these guys are all 0, so I don't need to worry about those. But this one, the top becomes 6 plus 4, that's 10, minus 8. So it's going to be 2 over 16. Okay? So you can go ahead and put that down here. Okay? So this implies that the center of mass is located at the point which comes with the coordinates negative 22 over 16 and 2 over 16. Okay, center of mass would come with those coordinates. Okay. All right, so this is already a long video. I'm gonna stop right here. If you have any questions or comments, please send those to my way, and I'll see you in another video. Bye.